Well, the second oral communications will be start with Daphne López Marcos from iuFOR, University of Valladolid.
Okay, first of all, I would like to congratulate to Professor Hans Pretz for his next appointment as an honorary doctor of our university, but also to the team that make it possible, because it's a really hard work, so thank you and congratulations. Now, passing to this presentation, I think that at this point of the symposium, maybe it's not necessary to talking about of the benefits of the mixed stand over the monospecific stands, but maybe that is necessary is talking about of the species that compose our mixtures, because there are many literature that talking about of mixtures of coniferous and deciduous, but it's not so common the literature that talking about of mixtures of coniferous and coniferous. But this type of forests exist, and this type of forest exists also in Spain, as the mixtures of Scots pine and maritime pine. For that, we think that maybe these mixtures of coniferous trees maybe could show the same behavior that the mixture of coniferous and deciduous, and maybe could show also a competitive advantage over the monospecific stands in terms of ecosystem service supply. And for that, we select two ecosystem services to analyze in a triplet say. We analyze the biodiversity conservation, but also the soil carbon sequestration. For that, in a permanent essay of iuFOR in the Sierra de la Demanda, we select 6 triplets, and each triplet are composed by 3 circular plots of 15 meters radio, 1 pure plot of Pinus sylvestris, 1 pure plot of Pinus pinaster, and 1 mixed plot of both species. And the characteristic that must to be located less than 1 kilometer to each other in order to the environmental characteristics must to be so similar, and several characteristics as age, density, basal area, or so whatever, must to be similar inside of the triplet, but could be different among the triplets. Okay. And inside of each plot, we analyze 3 different ecosystem parts or compartments of the ecosystem. We analyze the overstory, the understory, but also the soil. Talking about of the overstory, we analyze this overstory at 2 different spatial scales. At plot scale, analyzing all the trees that we found, but also at a small scale, analyzing 10 subplots of 4 meters radio inside of each plot. Talking about of the understory, we analyze the species composition, the life form composition, but also several diversity index and the regeneration of the main trees. And talking about of the soil, we analyze the soil in 2 dimensions. In surface, analyzing also 10 subsamples in the soil, analyzing only in the top soil, the first 5 centimeters, in order to analyze the variability inside of each plot. And also we analyze the soil in depth, analyzing 1 pit plot up to 50 centimeter depth in each plot. And what we found? Okay, we found that this mixed stamp of Scots pine and maritime pine show a competitive advantage over the monospecific stands in terms of ecosystem services supply. And in which ecosystem services? In biodiversity conservation, in soil carbon sequestration, but also in soil fertility and in forest productivity. And in which way? Okay, talking about of biodiversity conservation, we found that these mixed stands are able to achieve greater understory species richness than expected given the soil conditions, because when we analyze the water retention in soil, we found that the pure stands of Pinus sylvestris show the better conditions, pure stands of Pinus pinaster show the worst condition, and the mixed stands show an intermediate situation of the water in soil. And with this water condition, to in comparison to the Pinus sylvestris plots, we found that these mixed stands are able to achieve the same rate of the understory richness, and it is nice. Also, talking about of the biodiversity conservation, we found that in these mixed stands, we found the regeneration of both Pinus species, but also the main regeneration in these mixed stands belonging to other species, belonging to the native close oak. And we relate this regeneration of this native close oak with this greater understory richness, because there are some species that contain this regeneration of the oak. Now, talking about of the soil carbon sequestration, we found when we analyzed the soil carbon sequestration in depth that these mixed stands are able to achieve greater carbon stock, but in subsoil layers, not in the topsoil. And this is interesting because in these subsoil layers, the carbon is more protected for every disturbance, for example, the climate change or the fires or whatever you want. Okay. And talking about of the soil carbon sequestration, but in surface, analyzing the variability of the carbon of the organic matter in these plots, we found that these mixed stands are able also to achieve higher topsoil organic matter quality. It means I'm talking about of the ratio of carbon and nitrogen than expected given the overstory composition and given the leaf litter composition, because these both species have several different characteristics in the leaf litter. Talking about of the soil fertility, we found that also these mixed stands are able to achieve greater example cation stocks, because we found that these mixed stands show a greater first horizon than the pure stands. And if you remember your lessons of social science in your degree, this first horizon is the horizon that stores more organic matter, more nutrients, more water. And if your first horizon is deeper in the mixed stands, it's better to storage more nutrients. And passing to the forest productivity, when we analyze these ecosystem services, we found that also the mixed stands are able to achieve greater basal area, but only detected at a small scale. Because when we analyze this at plot scale, we not detected this effect. But when we analyze, when we decrease the scale, we found this effect, and we relate this with the distance among the trees, because when we analyze the distance amongst for example, the species, for example, the silvestri with other silvestris, the distance among the silvestris in the pure stands are longer than in the pure stands. And the same occurs with the Pinus pinaster. But when we analyze the distance among the trees independent of the species that they belong in, the distance of the trees independent of the species are shorter in mixed stand than in the pure stands. And it means that the trees that is closer in mixed stands belonging to different species. And we relate this with a complementary use of the resources in the soil, and we test this with a bidimensional niche analysis of water and with fertility in soil. So to conclude, we could conclude that, okay, this mixed stand of Scots pine and maritime pine show a competitive advantage over the monospecific stands in terms of ecosystem service supply, but also that some of these effects are only detected at a small scale. For that, we think that it's necessary to combine studies at several spatial scales. But also, we found that these ecosystem services are connected, because if you remember, where our objective was only analyze two ecosystem services, biodiversity conservation and soil carbon sequestration, but we found effects also in two more ecosystem services, in fertility and productivity. And this is interesting because if we have some actions in one part of the ecosystem, maybe we have a reaction in other part of the ecosystem, because some of these ecosystem services are mostly linked only to one part of the ecosystem, as, for example, the biodiversity conservation are mostly linked with this understory. And if we have some action with this understory, maybe we have a reaction in other parts of the ecosystem. For that, we think also that it's necessary to combine studies more specifically with studies more holistic that include all the ecosystem, from overstory to soil, but also including the understory. So that's all, and thank you.